Hello, am I audible? Anyone, please?
Yes, sir, you are.
Okay, so very good
Yeah,
evening.
yeah. Hello, sir. Good evening.
Good evening to all of you. So basically, this session is about week 9, open session for week 9. So, meanwhile, how many of you have covered the lectures video of week 9, random variable, PMF, CDF, and all things?
Done, sir.
Done. So you got the concept of random variables, probability mass function, cumulative distribution function. I
Yes,
think
sir.
it's an easy topic than permutation combination.
Yes, easy than previous ones.
Yeah. So, whether we should start with any one of you have doubt in week 8 graded assignment? So we can start with the week 8 graded assignment questions. After that, we can move week 9, or we can do these things, or we can do like first we will discuss the week 9. After that, we can discuss the week 8 graded assignment. So what will be, according to you, which will be so we should start with the week 8 graded.
Anything is fine, sir.
Okay, so yeah, then yeah, let's go with the week 8. Yeah, so is there any difficulty you faced for the first question? Or you people were able to solve the questions?
The first question I've done that.
So you got correct, or you faced difficulty? Anybody? If you have doubt, then we can discuss it. First of all, you know the meaning of 5-wicket horse?
Yes, sir. Like getting 5 wickets in a match. That's a 5 wicket haul.
Yeah, getting 5 or more wickets in a single inning, right?
In a row.
So
Like at least 5, right?
yeah, at least 5.
At least 5.
Okay. So this question, you people were able to solve it, or should we discuss?
Sir, can you discuss each and every question from this graded assignment?
So see, thing is that we can discuss, no issue, but
sir, I got this first question wrong.
okay.
In my question, in place of the 6th, it was 9th.
Yeah, it's the different for
That will be
everyone.
the 9,
But the answer,
7.
in answer, I could not understand how it is 1 by 9. So
Okay, so these 4, 15 are same.
yes, sir. Rest of the portion was same, but 1 by 9 into 1 by 9 was there. That I did not make it correct.
Okay.
That value will be different for each of the question. Everyone's question, the value will be different. Value will differ.
So
But
question
the
is,
logic will remain same.
Zahir Khan has taken 4, 5 wickets all in his last 15 matches, correct? So his match records are selected and random and one by one analyzed. Then question is, none of the match records is analyzed more than once. Then what is the probability that the 9th one? I mean, you are talking about this.
Yeah. Yes,
is
sir.
9th. Okay. So total matches he took, there is 15, correct? Right? And
Yes.
question is, Zahir Khan has taken 4 5-wicket haul, right?
Yes.
So he has taken 4 5-wicket haul, correct? And question is saying, what is the probability that according to your question, 9th one analyzed is his last 5-wicket haul. Question is ninth one analyzed is his last 5 wicket. Okay.
Yes, sir. Yes.
This is clear so far. Now question is
Yes.
so that means what I can say. See, ninth one. See, total matches are 15. Okay, so ninth one analyzed is his last 5 wicket haul. That means in total, how many 5 wickets haul we have? 4. Correct. That means remaining 3 wickets haul. Okay, remaining. Okay, first of all, in how many way I can choose? Okay, so tell me in how many way you can choose the remaining. Sorry, what was the question? 6. Yeah. So see, ninth one is the last 5 wicket haul. So that means if ninth one is the last 5 wicket haul, so remain 3 wickets haul will be out of 11 8 matches.
Yes, sir. Yes, sir.
Are you getting?
Yes,
See,
sir. Yeah.
there are total 15 matches. So ninth one is if it's last 5 wicket haul, that means 3 wickets is 5 wicket haul is
Will
out
be
of 8.
out of 8. Yes, sir.
Correct.
Excuse me, sir. Here, the last 5 wicket haul is just a single quantity here.
Yes, just a single quantity.
Okay. Okay.
Okay. So in how many way I can choose 8 matches?
15C8, sir.
15C8.
15C8. Okay.
8.
Correct. In how many way I can choose the C? In total, I have 4 5 wicket haul. So in how many way I can choose the 3 5 wicket haul?
8C3.
No, no, no. I'm asking I have total
Out
4
of
5
4.
wickets haul.
4C3.
So I can choose in 4C3.
4C3.
Correct. Into out of remaining see 11 matches, I can choose the 5 matches. This is for 5 wicket haul. This is for the remaining. See, in
Sir,
total,
how we are getting that 11?
1 second. See, in total, I have 15 matches. Correct.
Okay.
Yes, sir. Yes, sir.
So forget about this. See, ninth one is the last. That means I have to consider now 8 matches.
Yes.
And in total, if ninth one is the last 5 wickets haul, that means I can choose 3 wickets haul out of 4.
Yes.
So remaining matches is I have 11.
Total we had 15, right?
Total we had 15, in which 4 are 5 wicket haul. That means 11 are remaining.
11 are remaining. Yes.
If you are choosing 3 5 wickets haul, that means 5 are remaining. We will choose from the 11.
In total of 8.
Correct?
From a total of 8. Yeah.
This is for
Okay.
the 3 wicket haul. Okay.
Okay.
Yes, sir. Yes,
So
sir.
what is question is saying ninth one analyze is his last 5 wickets haul. So what will be the probability for this? I have analyzed 8 matches. Then what will the probability for ninth one is the last 5 wicket haul?
Only one probability then left.
Only one probability.
Yeah, 1/9.
1/9.
1/9 or 1/7?
1/7, sir. We are left with 7 matches only.
7 matches.
Okay.
That's why it's a 1/7.
Oh, so 7 matches, 1/7 then.
Okay, so it's clear.
Okay, 15 minus 8, that is 7.
Yeah, that's 7.
So how have you written 4C3? Can you explain it once more?
Okay, so what is the question? Question is saying ninth one analyzed is his last 5 wicket haul. Okay,
Yes,
and
sir.
we have total 4 5 wicket haul. Okay, suppose
Okay.
F1, F2, F3, and F4. Suppose this is the ninth one analyzed. Okay.
Okay.
So for these 3, I can choose any out of 4, any 3.
Yeah, 4C3. Okay.
Okay. It's
Okay.
clear.
It's clear.
So any doubt in the second question? I think it's a simple one. I mean, any one of you have doubt or everyone got the correct answer?
I got it wrong.
Okay, so what was your approach? Can you tell me, Jira?
Sir, if you can give us 2 minutes, maybe we can try this question, all of us. And then when you explain, it will be better for us to understand.
So when you were submitting the assignments, you had tried or?
No, sir, I couldn't do it. So that's why I'm requesting for some time.
Okay, so okay, just do it. You have to.
Okay, thanks.
Yeah. So just read the statements of the question and we'll discuss it within 2 minutes. Okay, so you are trying now. So can you tell me what events you are making?
So we are saying that A can be.
So should I go?
Question is A and B predicts the outcomes of a cricket match, right? And their chances of predicting the runs scored by a specific batsman correctly are 3/6 and 2/3. Correct. So thing is that, and it's saying its prediction is independent of each other, right? So can we make a event like A and B predict predict the same score correctly, right?
Same
So we
score
can
or
make
their prediction will be correct. Like A's prediction will be correct in 3/6 ways, and it's correct in
we can
3
correct. So we can make events like both A and B predicted the score correctly, right? Both A and B predicted the score correctly, correct? I can make an event like this.
Yes, A intersection B.
So yeah, it's a intersection. I can make event second event like exactly one of them predicted the score correctly, right?
Yes.
Exactly one of them predicted the score correctly. What we can make the next event?
Both are incorrect.
In the question, it is also saying they predicted the same wrong score. Okay, so I can make event neither of them predicted the score correctly. Neither of them predicted the score correct. Okay, and there will be one more event. Let's say it's common event. Let's say E, which will be they predicted the same score. That is the another event. Okay, because I'm defining this event because it might possible they predicted the correct, but it may be it's the same score or different score, right?
But sir, this is confusing actually. So actually now you are creating, and then there can be many more events. Like you can say that they predicted the score incorrectly by a difference of 10.
No.
So
See,
there can
thing
be
is
many
that
such events, right?
I have defined the events based on the questions. Okay, so thing is that in the question it gives that see what we need to find here. We need to find that given that they predicted the same score, right? That means this event is given to us. So I can make an event, they predicted the same score. Then I have to find what is the probability that their answer is correct. Okay. That means what we need to find here. See, it's given that they predicted the same score, correct? It's given to me. That means this event, right? Question is what is the probability that their answer is correct? So what it will be? Probability of what? Their answer is correct, and it is given that they predicted the same score.
Okay.
So it's a even.
Yeah.
Correct.
Yeah.
So now, then what will be this formula? Probability of even given EE. I can write probability of even intersection E divided by probability of E.
Yes.
So far it's clear.
Yes, sir.
Okay. So tell me how we can find the probability of even intersection E.
They predicted the.
So I can apply multiplication rule.
Yes,
Sir,
sir.
we can
Even
remove the entire probability is 1, so we can remove the this probability, that is 1 minus of that value, because 1 is the entire probability that it is means they can be correct. They means they predicted the same score, or they predicted the correct score.
I'm not getting what you're trying to say here. See, this is clear, or these things. It's given that they predicted the same score. That means E is given to me. What is the probability that they predicted the correct? So E1, correct? So how we can find the probability of E given E1? First of all, tell me what is the probability of E1? And what is the E1? E1 is both A and B predicted the score correctly. Okay. So in the question, it is given that A and B predicts the outcomes of a cricket match correctly are 3/6 and 2/3. Okay. So I have made event E1, both A and B are predicting the score correctly. That means 3/6 into 2/3.
Probability of 3/6 into 2/3.
Why? Because they are independent also.
Independent event.
Okay. So it will be 1/3.
Yes.
Okay. What is the probability of E given E1?
We have to find the intersection now.
No. Try to relate meaning of E given E1. E1 is what? They predicted.
One is something that has occurred already, so it's already 1/3.
They predicted correctly. Given that they predicted correctly,
they predicted the same score, right?
Yes. So one only. That is one.
That is one. Yeah, this is the theory event.
Yes, sir.
Okay.
Yes.
It's given that they both and A. See, what is even? Even both A and B predicted the score correctly, and E is that they predicted the same score, right?
Same score, yes.
So this is the theory event, right? And what about probability of E? E means probability of they predicted the same score, correct? So how we can find this probability of E?
Means either they can predict both the correct score or both same wrong score.
So it will be E1 and E. I can write, or probability of E2 and E.
Yes, we can write
that. Means see, both predicted the same score. I mean, both predicted the correctly and same score, or neither of them predicted the correctly and same score, or what it will be next. So next I can write E3 intersection E.
Sir, can you explain this point please again?
Which point?
The last one. The statement you've written.
What is E? Is they predicted the same score, right? This is nothing but I'm trying to apply the law of total probability here. Okay. Because in the this is the base formula. So in the base, in the denominator, we this is about law of total probability. Okay. So what we can do?
They predicted the same score. Okay. So it's the intersection of they get the score correct. They predict the same score.
So what I can write to it? I can write probability of E1 into probability of E intersection E1. Correct? Plus, are you getting this point?
Yes.
By multiplication rule, I can write or not? And what about this quantity? Probability of E3 into probability of E given E3. Okay?
Okay.
So far it's clear?
Yes.
So we have found already this quantity. Probability of E1 as 1 by 3 into probability of E given E1 as 1. Okay? Plus, what about probability of E2? E2 is exactly one of them predicted the score correctly. So what will be the probability? What is the meaning of exactly one of them predicted the score correctly? That means A predicted the correct and B not, right?
Yes.
Or A not and B.
Yes.
Correct?
Yes.
It's clear for everyone?
Yes.
So see, in the question it is given that both they are predicting the score and probability for those it's independent of each other. So I can write probability of A into probability of B complement plus probability of A complement into probability of B, right? So what is the probability of A in the question? 3 by
3 by
6.
6.
And one probability of B complement 1 minus 2 by 3 plus probability of A complement 1 minus 3 by 6. Probability of B is 2 by 3. It's clear?
Yes.
Okay. So we can compute the values from here. I'm not going to calculate there. And what about next thing? We have to find E given E2, right? So what is the meaning of E given E2? What is the probability? E2 means what E2 is saying? E2 is saying exactly one of them predicted the score correctly, right? And E is saying they are predicting the same score. So what will be the probability? So hello.
Yes, sir.
Yeah, I'm saying E2 is what?
E2 is probability of exactly one of them predicting it correctly.
And E is saying they are predicting the same score.
Same
so
score,
what will
yes.
the probability? Anybody who got the correct answer?
Sir, I think 0.
Why?
So it is.
It's 0 only.
It is
0
asking.
only. Right.
It is
Yeah,
asking
it's
the
Yeah.
probability of same when one is
Yes.
correct. But
It is not
Yeah.
possible
it can
that.
be. It cannot be same if they
Yes.
they are
Yes,
not.
yes.
correct. Yeah, it will not.
Yes.
Then probability is saying probability of same given exactly one are predicting the correctly. So that is the something not possible, right?
Yes.
Okay. So
Yes.
this quantity will be 0. This whole quantity will become 0.
Yes.
Okay. So what is the probability of E3? See, we have to go with just a statement. Probability of E3 means what is E3? E3 is neither of them predicted the score correctly. That means what?
That means
A complement and B complement.
Yeah.
Correct?
Yes.
So probability of A, since these are independent, so I can write probability of A complement to probability of B complement. So just write 1 minus it's probability 3 by 6, 2 by 3. So 3 by 6 into 1 minus 2 by 3. Okay. What about probability E given E3?
So E3 is.
In the question, it is given that probability of them predicting
given in the
the same
question.
wrong score is 5 divided by 215, right? So E3 means what? Neither of them predicting the same score. I mean, correct, right? That means both are predicting the wrong. And
Yes.
E, they are predicting the same score. I'm saying both are predicting the wrong and they are same. That means this probability is given in the question, right?
5 by 2.
So 5 by 215. So we have to just put this value, and this quantity is already 0, and this value in the question, and we need to add, and we'll put here and we will get the answer. So we have to just see, we have to just clear with the statement of the question, and that's all about this. Okay, it's clear. So is it clear for everyone?
Yes, sir. Clear for me.
Yes.
Okay,
Yes,
so
yes,
what
sir.
about 3 and 4?
Yes, sir.
3 and 4 is
Actually use the base theorem to solve that, sir.
yeah, it's a it was base theorem. Yeah. What about 3 and 4?
Like I actually took only 2 cases actually.
Okay. You got the correct answer, right?
Yes, sir. I have also.
Yeah, you can do anyway. See, there might be
Yes,
different
I got the
approaches.
correct one.
There might be different approaches, but thing is that you have to be clear what's given in the question, what on. That's all. So in the probabilities things, so you have to be very, you have to carefully observe the statements or events. Okay. So what about question number 3? Everyone got the correct answer? I think this is the simple one.
So if you
These
can
are
give
not
two,
correct.
Sorry?
if you can give 2 minutes, we'll try and if
So you are saying you can try, and you had not tried the graded
Yes, sir.
when you are submitting the graded assignments.
Sir, I didn't get time to complete the graded assignment.
So you can try on your own, because this is, we have to discuss the things. Okay. So yeah, any one of you got the incorrect answer, or it was okay for everyone? See, if you are not saying
Yes,
anything,
sir.
then I will assume yeah, you got the correct answer. Then I will move to the week 9. Okay, what about question number 4? Is there anybody who faced the difficulty?
Sir, I don't know what did I do wrong in question number 4, but I have got the wrong answer.
Question number 4.
I don't know what did I do wrong. Yes, sir.
So question
Like
number
it,
3.
the range is 0.1 to 0.16. I got
Point,
2.
0.1 to 0.16. Okay, what was your answer?
Yes, sir. Yeah, the range is 0.16. I got 0.4 actually. Yeah, 0.4.
So it might be. What about question number 3? You got the correct answer? Because
Yeah. Question number 3, I got the correct answer. It's
question number 3 and question
0.09
number
for me.
4 are same. I mean, not same. Question number 3 about
Yes,
law
sir,
of
but
total probability.
the logic is same, sir.
Yeah, logic is
Yeah, and that's a base theorem for.
for 4. So you can check your calculation.
But I might have made some calculation mistakes,
Yeah,
so I
yeah,
don't
yeah.
know.
Because,
Yeah, exactly. I was saying the
yeah,
same
thing
thing.
is that if you
I
got
might
the
have made
correct
some
answer,
calculations.
yeah. Thing is that if you got the correct answer for question number 3, that means you have denominator things okay, right? And for numerator things, you have to just
Yes, sir.
find the problem. Okay. Yeah, just please check the things. If not, then you can let me know. Okay. So what about
Okay.
question number 5? It was clear for
Okay,
everyone?
sir. Okay.
It was okay for everyone?
Sir, I got the answer wrong here. Basically, the range. My answer was just out of range.
So you can recheck your calculation for this. You understood the concept behind this question, right?
These are
You guys?
independent events, right? So basically, we have to apply that logic that these are independent events. So if there are 3 persons who will complete the task, then we can create 3 events. Person will one will complete, person maybe person 1 and 2 may complete, and maybe person 1, 2, and 3 may complete, or neither can complete. Then we have to add the individual probability or
No,
multiply.
it was asking about task will be completed, right?
Okay, so then yes, okay, then we have
So
to just check that, right? Actually,
yeah,
I did it.
So,
I
sir,
did it.
work not done. I mean, 1 minus work not done by everyone.
yeah.
Yes.
See, thing is, question is given to us. Manoj, Kalpana, and Ananya complete. I mean, probability of completing a task is 3/4, 2/8, 3/8, right?
Yes.
So I can make event A task is completed by what's the Manoj, Kalpana, and Ananya. So say task is completed by Manoj. Okay. I'm saying B task is completed by Ananya. Okay. Third person is task is completed by Kalpana. Okay. So thing is that question is saying what is the probability that task will be completed. So when task will be completed,
If anyone can complete the task,
anyone
then
can complete the task, right? So I can write it 1 minus by the see, I can write 1 minus A union B union C whole complement.
yes,
Okay. By the De Morgan's law, I can write these things as same as probability of A complement intersection B complement intersection
yes,
C
yes, yes,
complement,
yes,
right? And I taught in the last session, if A, B, and C are independent, that means A complement, B complement, C complement will also be independent, right? So that means 1 minus probability of A complement into probability of B complement into probability of C complement. I can write.
yes, yes.
Okay. So just put the value of probability of A complement, B complement, C complement, and 1 minus, you will get the answer. That's all.
Actually, sir, I have different value for Manoj, Kalpana, and
Yeah, it's a different values for everyone. It's not values are not same.
Sir, in general, when we will compute the probability of A complement, then we will use 1 minus that value of A.
Yeah.
Yeah, I got it. Means basically my value was means it was, what was the value? My was 0.88. That's why it was wrong.
Yeah, it's a different for everyone, so you can check. Okay.
it means the answer range would also be different.
Sorry.
Yes.
Yeah, it's a different. See, if values are different, then answer range is also different. Okay. Range is given to all of you according to the values. Okay.
Yeah.
So what about question number 6? It was clear, okay for everyone.
Yes, sir. For me, it's okay.
And what
yes,
about question number 8, 9?
Yes, sir. Yes, sir.
So it's basically based on this table. So it's a simple thing, right? Any doubt? 8, 9, 10, any difficulty?
No, sir.
Yes, sir.
And 11? 11 is again about, I think,
Bayesian probability.
yeah, it's a Bayesian probability.
Yeah, we have to apply.
So any one of you have done correct? I mean, got wrong, or it was okay for everyone?
I got it.
Okay, so I'm hoping because
Yes, sir. Got it right.
okay.
Sir, but in the lecture, like in the lecture, if somebody, I just have a general question, like if in the lecture I go through all the lectures, okay, but I see, and this is the first class I'm attending for statistics only, but
Okay.
but in the lectures, all this is not covered, sir. Most of the formulas you have used, they are not covered. So how, somebody?
No. Things are covered, I think.
This one is not covered, sir.
This one.
In no lecture is it covered.
This one.
Morgan's law, that's common.
It's the De Morgan's law, normal 11, 12.
Yes,
and
sir, I
first
did
thing,
11, 15 years ago, so that's the problem.
Yeah, Asu, thing is that I think, as I can remember, in some of the session I had derived this values also, this probability with the Venn diagram. Okay, so thing is that I think you might miss that session. So in some of the sessions I have discussed this probability, and it's a simple De Morgan's law. Okay, so you can see, this is the thing. And one more thing, there is another approach also. You are saying this formula is not given to you. Okay, so there is another approach. Suppose there is Manoj, Ananya, and Kalpana. Okay, Manoj, Ananya, and Kalpana. So when task will be completed, when Manoj suppose is done, Ananya and Kalpana is not done. Manoj is not done, task is done by Ananya, by Kalpana it's not. And okay, if there any of two are completing the task, that means task will be completed. So like this, and there will be one more cases when all the three persons are completing the task. Okay, so what we can do here, that means A union, B not union, it's A and B complement and C complement. I can write,
Yes.
right? What about A complement intersection B intersection C complement,
C complement. Yes.
A complement intersection B
Intersection B
complement
complement.
intersection C, A and B and C complement, A and B complement and and C, right? Cross means task is not completed by that person.
So A
A
complement.
complement B and C, and A and B and C. So you can apply the independent formula. You can add all the probability. So there is this approach as well. So you can do in any way. Okay, you will get the correct answer. Is that clear? Yeah.
Sir, I have just two things to say.
Mhm.
First one is from question 1 to 4. Means the logic building was very hard for me. So I may have to work on that. And from
Yes,
after that, I got it. And second thing is I don't know whether I feel it or I have talked with many of my friends. I think that course is going a little bit fast. Means in qualifier when I was studying, we were
Okay.
not doing everything so fast. Means in general, if you see what is the deadline for week 9, I think just 4 days after, right?
No. See. Thing is that we have extended the weekend graded deadline of the weekend graded assignment. Okay. Normally due date is on Wednesday, right?
Yes.
And we release the content on every Friday.
Yes.
Okay. So
Is it
week
this?
9
Is it?
syllabus has been already released 1 week
Mhm.
before. Okay. So it's
Sir.
on how you are managing the time and
I have the same feedback, sir. And also, I would like to share this one. Like this course is for actually advertised like it's for everybody. And
yeah.
now when you are explaining, you are telling that this is covered in 12th statistics. So it's not actually okay, because if that was the case, then we should have been somebody who has been working for 15-20 years. It will be life will be very difficult.
Yeah. Asu, I got your point. So that's why I said, see, you are attending this the first session today, right? And we have discussed such type of things already in this session.
Yes.
The thing which are little bit different, something formula is different. So we are discussing the session. You can ask the remaining people as well. And suppose you are not knowing this formula, okay? Then there is another approach you can. There is another method you can approach with that. So you can go. I agree with you. Like it's a difficult to manage all the things, job and all things. But yeah, there is some criteria, some agenda, some rules here also.
Oh, means, sir, can I speak a little?
So
Sir, can we also solve the previous question through tree diagram method?
Richu, you can make the tree. See, tree diagram is something you can make. Okay, sometimes it's got complicated. Okay, so you can make A and B, A not B not, and all things. So you can.
I'm sorry, sir. I joined a bit late, and my confusion is regarding question number 2. I did it, but I got every time different answer for question number 2.
You can rewatch these things we have discussed here. Okay.
Yeah.
We have discussed little bit before. We have discussed clearly. Okay. So
Yeah.
just you can rewatch.
Sir, first question that Zagar Khan wickets you have discussed, sir, already.
Yeah. First question, second question. We are actually we are discussing questions in sequence. Okay. So now we are on 12th question.
Okay.
So you can just try to rewatch. Otherwise, at the end of this session, we can discuss again. Okay. Because after this, we have to discuss the week 9.
Week 9.
Is that clear?
Yes, sir.
Yeah. So what about question number 12? It was clear for everyone? or any of you had difficulty regarding this question?
Sir, I had difficulty, sir.
So what, I mean, at what point you got stuck?
Just one second. Let me remember what I did.
So the last question is so like is similar with the example that you given us in previous lectures, right? The dark chocolate and milk chocolate. The last question, it's very much similar with the dark chocolate and milk chocolate example
It's
that
a
you
something
gave
that,
us.
it's like something that, and it's a similar one. So here, see, there was two phrase, right? I took the example of something two phrase, if I can remember. Here it's a two shops, right?
Yeah, two fridge. Yeah.
And there was two fridge and some dark chocolate, white chocolate.
Yes, sir. Yes, sir. Yes,
I
sir.
don't remember exactly same number, but yeah. So here we have two shops, shop A, shop B. Okay, and shop A has a stock of and red and two black t-shirt. Okay, so I have two shop. This is shop A. Let's say this is shop A, and this is shop B. Okay. So in the shop A, and red and two black t-shirt. Okay. So here and red and two black. Correct. And in shop B, two red and black. Okay. So two red and black we have. Okay. Question is, one of the shops is selected at random and two t-shirts are purchased from it. Okay. If both the t-shirt, okay, let me make the event. So I can make event, let's say even as shop A is selected, I can say or not, because I'm in my question, we are going to select the shop, right?
Yes, sir.
I can make the E2, shop B is selected.
Yes, sir.
So far it's clear for everyone. Now,
Yes.
question is, next is saying if both the t-shirt purchased are red, then what is the probability that it was from shop A? It is, so I can make the event E, two t-shirt purchased are of red color. Two t-shirts purchased are of red color. Okay, I can say. So in the question it is saying if both the t-shirt purchased are red, it's given. Okay, then what is the probability that it was purchased from shop A? So question is both t-shirt purchased, that means this is given to me, then probability that it is from shop A. This thing is saying in the last statement of the question.
Yes.
Correct.
Yes,
so
sir.
that, and this probability is given to us is as 6/7. This things given to us 6/7. We need to find the value of n. So now we need to expand this formula. So I can write probability of E1 intersection E divided by probability of E.
Yes.
Okay. So what about probability of E1 intersection C? But means two t-shirts purchased from red color and it is from shop A. So I can write probability of E into, sorry, E1 into probability of E given E1. That means shop A is selected into probability of two t-shirt purchased of red color. Okay, divided by probability of E. It's clear now so far?
Yes.
So what about this? What is the probability of E1? E1 is nothing but shop A is selected and we have two shop A and B. So what will be the probability of E1? It's nothing but 1/2.
Half.
And what is probability of E2?
And another one is half as well.
And then because I have only two shop, I can select the shop A in 1/2. I mean, probability of selecting shop A is 1/2 and probability of selecting shop B is 1/2. Okay. What about probability of E given E1? Means shop A is selected, it's given, and two t-shirt purchased are of red color. What is the probability? And in shop A, there are n red and two black t-shirt. first of all, I need to select the in the question it is saying I have see 2 t-shirts are purchased, right? So from shop A, in how many way I can choose, I can purchase the 2 t-shirt?
So n plus 2.
The NC2 by
Yeah.
n plus 2 C2.
Yeah.
So
Yeah.
total t-shirts are n plus 2. I can choose the 2 t-shirt in n plus 2 C2 way.
C2.
Correct?
Yes. Yes.
What is the in how many way I can choose the red color t-shirt? Because
N
in
by
the
2. NC2.
NC2, right?
Yes.
So we can solve it. So we will get n factorial 2 factorial n minus 2 factorial divided by n plus 2 factorial into 2 factorial and n factorial, because n plus 2 minus 2 it will be. So from where we will get 2 factorial will get cancel out. We will get n into n minus 1, right? See, n factorial I can write n into n minus 1, n minus 2 factorial divided by n minus 2 factorial whole division n plus 2 into n plus 1 into n factorial. I can write.
Yes.
So this will get cancelled out. This will get cancelled out. So we will get something n into n minus 1 divided by n plus 2 into n plus 1. Okay. Now, these things we have calculated. This is, now what about probability of E? What is the meaning of probability of E? That means probability of E is what? 2 t-shirts purchased are of red color, right? So how I can write this even this probability? 2 purchased 2 t-shirts which are purchased are of red color. That means what? That means what? How we
could be from shop A, so half into that value.
So see, in mathematical notation, yeah, correct, sir. We can write, see, what is the E? Is the both t-shirt purchased are of red color. That means what? Shop A is selected and it is from shop A, right? I can write it or not? Or
Yeah,
shop B
and E2
and
intersection E.
both t-shirt are red color. It's clear for now?
Yes.
Okay. So how we can proceed from here? Probability of E1 into probability of E given E1. This thing.
Yes.
Plus these things I can write the multiplication by the multiplication rule. Probability of E2 into probability of E given E2. Correct? So these things I have computed. It is nothing but half into probability of E given E1 is what? N into n minus 1 divided by this quantity. Okay. So I'm going to write it this quantity as capital N1. Okay. So 1 by n, capital N1 plus what is probability of E2? Half, because E2 is what? Probability shop B is selected. So probability of E2 is 1 by 2 into what will the probability of E given E2? See, probability of E
So it
given
will be
E2.
Yes, sir. It will be 2C2 by n plus 2C2.
Yes, sir. 2C2 by n plus 2C.
Correct. Because in how many way I can choose the 2 t-shirt n
Yeah,
plus 2
2C2 by n
C2.
plus.
Okay. Thing is that what is the E? E means the both t-shirt purchased are of red color. So how many red colors in the shop we have? 2. I can do these things in one way. That means 2C2. Not 1. See, 2C2 is 2. Sorry about that. Because I have 2 red t-shirts, so I can purchase in 2 way, right?
Yeah.
Okay. So this thing is clear. So it will be 2C2 divided by n plus 2C2. So here just we need to compute this quantity and we will have to put here and value of this. We will get the correct answer. So are you getting the idea about the
if
question?
possible, sir, can you summarize once, please, what we did?
Part
It will be very helpful, sir.
Can
If you can
repeat?
summarize once what we did, it will be very helpful.
See, question is we have two shop A and shop B, correct?
Yes.
And in the shop A we have n red t-shirt, B 2 black t-shirt. And in shop B I have 2 red t-shirt and n black t-shirt. Okay, and event I have made E1 as SOP A is selected and E2 as SOP B is selected. Okay, see, suppose you have two things, and then what is the probability of selecting the one things? 1 by 2.
1
You
by 2,
have,
yes.
okay, so probability of E1 is 1 by 2 and probability of E2 is 1 by 2. So far it's clear.
Yes.
Next event is E2 E as 2 t-shirt purchased are of red color. Okay, now
Yes.
question is, it is saying that probability of E1 given E, okay, is 6 by 7 is already given in the question. So what is the meaning of E1 given E by the conditional probability formula? I can write probability of E1 intersection E divided by probability of E, correct?
Yes.
So this intersection quantity I can write the by the multiplication rule, probability of E1 into probability of E given E1 or not?
Yes.
Correct. What is the
sir,
probability of E? Yes.
what is the meaning of P E1 intersection E? Meaning in plain English?
What is the meaning of
P E1 intersection E?
E1 intersection E?
Yes, sir.
So it's a simple thing. SOP A and 2 t-shirt purchased from purchased are of red color.
Achha, are of red color and from SOP A.
From SOP A. Okay.
Okay.
I will come to that one. So this numerator is clear. Okay. So this probability of E1 I have 1 by 2 and probability of E given E1 means what? See, E1 is given to me. It's given to me means SOP A is selected, it's given. That means now we are going to consider only SOP A. So what is the probability that if SOP A is selected, what is the probability that both t-shirts are red color? So for the probability, we have to go with the favorable cases divided by total number of cases.
Yes.
So in the SOP A, I have total n plus 2 t-shirt, of which n are red, 2 are black. Correct? So
Yes.
n plus 2. So in how many way I can choose the 2 t-shirt? N plus 2 C2. Correct?
Yes.
And E is what? Both t-shirts should be red color. That means how many red colors we have? N. So NC2. We have to solve this quantity. Now come to the this probability of E. Probability of E means what?
No,
Both
but one thing, sir. So now
Mhm.
all this we have done now. Why again we are coming here to probability of E?
Okay. How will you compute this probability of E?
Acha, that was for the denominator calculation we are doing this now.
Yes, we have to do these things.
Okay, sure.
So probability of E means probability of both t-shirt purchased are of red color. Okay. So suppose when you will purchase the both, two t-shirt and both are red color. It means I can write E1 SOP A and I can purchase the both t-shirt, right?
Yes.
Then I have the event of purchasing the both t-shirt are of red color, or probability of SOP B and both are red color.
Yes.
Okay, and I can apply the formula of multiplication rule here and we will get the, okay.
Yes.
So N1 means here I have written this quantity also, so you can just put the value and you will get the answer.
Okay.
So it's clear for everyone now?
Sir, 1 second, sir. That shop 2, shop B,
Mhm.
there are only 2 red t-shirts are there.
Okay.
So to select 2 red t-shirts, there is only one way, no, sir? How we can directly take it as one way, no, sir? So 2C2 by n plus 2C2, the value will be 1, isn't it, sir?
Yeah, so that, see, that is the one way I have written the in general formula. See, 2C2 divided by n plus 2C2. Okay.
Yes, sir.
This is the probability.
Okay.
Okay. I can write, you are saying 1 by n plus 2C2.
No, the event is given, no, sir. We are selecting only 2 t-shirts, sir. Yeah. In how many ways? What is the probability we will select 2 t-shirts? Is 1 by n plus 2 by C2. Yes, sir. Correct.
That is, so both are same.
Okay. Okay, sir. Okay.
It's clear now?
Okay, sir.
Okay. Yeah. It's clear, Asu, Naren, and everyone, for everyone.
Yes, sir. Clear from me also. Yes.
Okay, thanks. So now we can move to the week 9. Okay. So week 9 is about random variables. So how many of you have covered, got the concepts of random variable and all things?
Sir,
Only random variables, sir.
I have seen the videos, sir.
Okay. So you can simply interpret the random variable is nothing what? Here is the definition, right?
A
Which
real
option
valued
should be correct?
function. Third one, sir.
Real
one,
value
right?
function defined in sample space.
Okay. And what about question number 2?
Third one.
Range of a random variable x is the set of all possible values that x can take, and y be a random variable defined as number of tosses until the first hit comes. Okay. Tossing coin, then what will be the range of y? So tell us.
1, 2, 3.
1, 2, 3, sir.
Third one.
Third one.
So
Why not
third one.
second or fourth?
Third one.
Why not second or fourth?
Because
The second, so we are tossing, so there must be one outcome. So the first toss
Correct.
might get 1, so
Correct.
that's why it
Correct.
can't be 0.
Yes, correct. It is asking about number of tosses until the first hit comes. Okay. So you required at least one toss. What about question number 3?
So for the aces, so it would be 2, 3 to till 20. Since I could pull out 2 aces, so the minimum value would be 2.
Okay.
last one.
3
Last one.
till 20.
Okay. One thing, please tell me. Should we go each question wise, or any one of you have doubts, so we can discuss directly?
Sir, I have doubt. I have already went through. I have doubt. I can tell the question.
Okay. So which one will be better? Should we go?
Sir, if you can
raise
discuss
hand
the
or
concept also.
sorry?
You can discuss the concept. Means I haven't
Okay.
gone through all the videos. So in summary, if you can.
Okay. So see, random variable is nothing but
I understood that. The
see,
main
thing is
concept
that random
behind.
variable, yeah, random variable you can interpret as a general idea, like it is nothing but a numerical description of the outcome of your experiment, right?
Right.
You
We
can say,
can.
I can say I'm doing an experiment, so numerical description of the outcome of that experiment, correct?
Yes. Your experiment will be same, and
Yes.
the event will be event can vary.
So yeah,
Event can vary.
event can vary. So because event is nothing but the subset of the.
Yes.
So yeah, here x be defined as the sum of the points of withdrawn cards. So it is saying face card carries 10 points. So maximum will be 20.
20, yes.
And
We can
minimum,
draw
see, it
2,
is saying ace carries 1 point. So minimum will be 2. So 2, 3, it can be 2, 3 onwards 20. What about question number 4?
So this question I have a doubt. I don't know why I'm getting 2 values. Once I'm getting 64, once I'm getting 69. Sorry, 68. Sorry, 68.
Is saying.
So if you can just give,
Okay.
put some light on it, please.
Okay. So how by what approach you got the 64? Hello.
So give me a second. Fine. There are a lot of questions.
Okay. So for each face card carries the 10 points, right? So face card is king, queen, and jack. Are you familiar with this? King,
Yes,
queen,
sir.
jack are the face card. So these 3 cards
Yes,
are carrying point 10, and there is an ace in each suit which is carrying 1 points, and there are 2 to 10
Which carries the same number of points.
same number. There are cards which are numbered 2 to 10. Okay. Now, so these are for every suits, right? And there are 4 suits: club, spade, diamonds, and hearts, right? There are these 4 suits. Okay. So thing is, question is saying, how many outcomes will result in x equal to 19. Okay, so it is asking about how many outcomes will result in x equal to 19. Okay, so for getting 19, let's consider with the first suit, club. So for the club, how many in how many way we can get the 19?
4 4s are 16.
So one way, sir. No, not one way, sir. One face cards each with 9.
Okay,
That's
one
4
second.
ways.
Tell me.
Face
In how
card we
many
have
way
to
we
find.
can get 10? Say for getting 19, I should have one card as 10 and second card as 9, right?
Yes.
10.
So in how many ways I can
Yeah.
get the 10 cards with number 10?
4.
And in how
4
many
ways,
ways
sir.
I can get the card number with 9?
4 into 1, sir.
For clubs means only 1, sir.
For 9 in total out of 52 cards.
Club is 1, sir. It's 1 9
No,
only.
I'm not going to consider club. I'm asking in how many way we can get the 9.
4.
4 ways.
Because in each suit I have 9.
Yes, sir. That is 4, sir.
That is 4. So this is 16 way in general, right?
Yes,
If you are going to consider the club, this is for a single suit. So for the 4 suit, it will be 4 into 16. That's all.
Sir, I did in a different approach, sir. I mean, to get the 64. But yeah, the logic I got it. But sir, I don't know. Sometimes I'm getting different.
Yeah. What was your approach?
I might have made some mistake, but my approach was like I found it finally. So my approach was like I did take the first same like that, like first case, second case, third case, and fourth case. So I got 4 each. So 4 raised to 4, which so I got like that.
4 is 4 4.
Sorry, 4 raised to 3 I got.
No. Can you repeat what you're saying?
Like sir, for first case, like for first there is 4 ways. For the second, as like for the second suit, that would be 4 ways as well.
Okay.
And for the third, that would be 4 ways as well.
For what?
So I did the for sir the entire thing. I think I made a mistake. I mean the logical error I have done because there are 4 suits. This is giving like 3, like according to my approach.
Okay, one more thing. One approach you can do. See, there is club, spade, diamond, and heart. Okay. So for club, how tens we have?
4.
For spade?
4.
For diamond?
4.
For heart?
4.
So how many these are total?
16.
Correct. And how many 9 we have?
4.
That's all.
Okay, sir. Got it. Sir.
Got it? You
Sir,
can consider for a single suit, then you can add 4 and all things. So
yes, sir. Yes, yes,
anything
yes,
will be fine.
Sir, why we are not considering only a single suit?
That's why I have discussed. You can consider the single suit also.
Okay.
Okay.
Sir.
So see, for club, you have 10, 4, 10, right? And you can take any 9, any of the 4 9, 1 9 from the club, 1 9 from the spade, 1 9 from the diamond, 1 9 from the heart. You can take. Okay. So in how many way you can take? 4 into 4, 16.
Yes.
For the spade, again I can do in 4 into 4.
Yes.
For the diamond, I can again do in 4 into 4.
Always.
For heart, I can do again 4 into 4. So again, it's just 64, which is nothing but
16
4
plus 6. Oh, got it.
But okay.
Sir, one technical.
Is clear for everyone?
Clear for me, sir.
Okay.
Sir, one technical doubt, sir.
Yes.
In the videos, ma'am,
Yes, I got it, sir.
The negative probability should not be negative to
Yes.
find. But on probability can never be negative, no, sir. It is always between 0 and 1, no, sir.
Yes.
Why? Specifically, we are thinking about negative probabilities.
No. Where we are going to consider the negative probability?
No, in the videos, ma'am is telling no, sir. One of the two, there are two important things you have to find out. One is it should be
greater or equal to 0, and it should be lies between.
Sir, for the PMF, sir, for the PMF.
This is
together.
right.
Addition of all the things should be 1.
Yes.
So 2 conditions are there.
Yeah.
But first condition, it is well known that it cannot, probability can never be in less than 0, no, sir. Then why?
Yes.
Why we have to think about that condition at all, sir? Obviously, the probability can never be negative. And in the one of the slides, ma'am is showing us -2. The probability as -2, not -2. In one thing she is showing, no, sir.
Okay, in which lecture you are talking about? Hello.
No, that to find out whether.
So I think it's a second last or the last one, because ma'am.
Yeah. See, thing is that, see, probability. See, for checking the PMF, that is the criteria for PMF. So for checking the PMF, there is criteria. Your probability should be greater than 0. See, sometime due to my calculation mistake, and suppose you are doing any calculation and you got the probability negative, that means you have made some mistakes. So check the things. All the probabilities should be greater or equal to 0. First criteria. Second criteria, probability should, it should be lies between 0 and 1. Second is sum of all the probabilities should be equal to 1. That is the conditions for the PMF. It's a general idea. Okay? It's not about something.
Sir, lecture 8.4 in about 12 minutes 40 seconds. In that slide, it is coming, sir. Example number 2.
8.4.
Lecture 8.4.
8.4 or 9.4?
And sir, 9.4, sir. 9.4. 9.4, sir.
As per, just like that, I was just seeing in the video.
Okay, at what time?
9.4.
What time?
12:40.
Okay.
In that lecture, in the second example, for the fourth x, when x is equal to 4, it is shown as -1.
Okay, so what ma'am is saying?
No, minus for condition for that my minus should not be there.
That's why it's not PMF.
Yeah, that is why it is not PMS.
Yeah.
But how will the minus will come? So that is my doubt. Why should minus come in probability? Minus can never come in probability, no, sir.
That's why
That's calculation error.
minus can never come.
That's why it's written. It's a simple
why
criteria.
So
minus should
PMF.
not be there. If minus
why
is there,
not
that means that is not probability. Sometimes due to calculation mistakes, some minor error, people got the values in negative or even more than 1 also. Okay. So that is the something criteria. You have to be clear. It's something probability should not be less than 0. That's all.
Okay. Now just to explaining the things, madam has shown like that.
Yeah. So be clear with the.
As in first case, going beyond 1, so that's why no is written there.
So we were at the question number 4. So question number 4 is clear for everyone?
Yes, sir.
What about question number 5?
0 infinity.
0 infinity.
That's
it's
correct.
for everyone.
0 to infinity, sir.
X is saying define as the time in hours from now until the next rain occurs in a certain city. Okay. So what are the values X can take? So it can take 0 hours to infinity. It can take any. Okay. So what about question number 3? 6.
C is the answer.
Okay. So what is the X? X is the defined number of heads.
3, sir. Number 3.
Number of tails. Okay. So it's possible number of heads can be 0 and number of tails can be 3.
Yes.
So it can be 0 minus 3. That means -3. And it also extreme case is there are all the heads. That means 3 minus 0. Right. So 3. Third option is correct. What about question number 7?
0.36 is the answer.
I got 0.36.
Okay, so it was for everyone.
Sir, I couldn't get this one.
Okay. Sir, if you can give 2 minutes, we can try it, sir.
Okay, we'll discuss it. Yeah. So 2 cards are withdrawn from a deck of 52 cards. Okay, one after the other without replacement. Random variable X is defined as 0 if both are face, 1 if one card is face, and 2 is none of face. So we need to find the probability of X equal to 1. So yeah, so X is what? It is saying 0, 1 and 2, right? 1 when both are face. I mean, sorry, 0 means what? Both are face card, right?
Yes, sir.
And 1 means?
If exactly one card.
Exactly, 1 is face card.
Yes.
And 2 means?
None of
both.
them.
None of, okay? None of them are?
Yes, sir.
Okay, so question is, we are drawing how many cards? 2 cards, okay, from 52. Question is, what is the probability of X equal to 1? So probability of X equal to 1 means what? That means one exactly 1 is the face card. Okay.
Yes, sir.
So what is the, see how many face cards we have?
12.
12 face card. 3 face card in each suit, right? King, queen, and jack. Okay. So what is the total number of case in which I can draw 2 cards?
52.
52 C2.
I'm asking about total number of case. So I can draw 2 cards in 52 C2 way,
Yes.
right?
Yes.
Now, X is representing the face card, okay? And X equal to 1 means we are interested in only one face card, and we have in total 12 face card. So for drawing one face card, in how many way we can do?
12 C1.
12
C1.
12 C1 into
Yes.
in total we are drawing 2 cards. One cards we have remaining. So I have already considered the 12 cards. So from the remaining 40 cards, I have to choose one card.
40 C1, yeah.
C1.
Yes.
Correct? So
Yes.
we need to just calculate the value. I think we will get the answer. Okay?
Yes.
It's clear now?
Yes.
Yes, sir.
So
Yes,
we
sir.
can, what about question number 8? 8,
B is the
9,
answer.
sorry?
B, second one.
The option 2, sir.
Yeah. So what is 8 is saying?
B.
A small village has 120 female voters and 90 male voters. So how many voters we have? 210, correct? A sample of 10 voters is chosen. Let a random variable X be defined as the number of male voters in the chosen sample. Then what is the probability that X equal to 5? So X is nothing but the number of male voters. Okay. Probability of X equal to 5. And we are choosing the 10 voters in total. So in total, we can choose 10 voters in 210 C10 way, right? And
Yes, sir.
X equal to 5 means 5 should be the male voters,
Yes,
right?
sir.
So that means 90 C5 and 120 should be female voters and
Yes, sir.
120 C5. That's all. Okay. Okay. Can you tell me what will the probability for X equal to 0 here? Anybody?
X equals to 0. X we define as the number of male. So X0 means
means
no,
no male,
all
only
female.
No,
females.
I'm
All
asking you
female. 120 C10.
120 C
C10.
divided by 200 C.
210 C10.
Okay.
Yes, sir.
And what about probability X equal to 3?
X equal to 3 means 3 males and 7 females.
Okay. Yes.
So 90 C3 into 120 C7 by 210 C10.
Yeah.
Correct. Now it's clear for everyone.
Yes.
Yes, sir.
What about question number 8?
So in this answer will be 0.729 as per me.
Okay, so is it for everyone? I mean, is there
I got
any doubt in this
0.75.
question? Who got 7.5? Hello.
Sir, I got 0.75. That's what I said.
Okay. See.
I said I got the answer 0.75 for question number 9. That's what I said.
Okay. We'll check. Question is saying an insurance salesman visits up to 3 clients each day, right? Hoping to sell a new policy. He stops for the day. Once he makes a sale, each client independently decide whether to buy a policy. 10% of the clients purchase the policy. That means 90% of the clients will not purchase the policy.
Yes, sir.
Right? X be defined as the number of sales he made in a day. Right?
Yes.
What is the probability of X equal to 0? First of all, what values X can take?
X can take 0, 1, 2, 3.
3, because he insurance salesman visits up to 3 clients, right? So number of sales can be 0, 1, 2, and 3, right? It is asking about probability of X equal to 0. So probability of
no sale.
X equal to 0 means probability of no sale on the day, on that day.
There's a no sale.
Yes.
No sale.
Not any sale in a day. Okay.
Yes, sir.
How many
Yes, sir.
clients he are going? He used to go in a day.
3.
3. So that means what?
So 3, sir. 3.
10% of the clients are purchasing the policy. That means 90% will not purchase.
Yes, sir.
Correct. So client 1 did not purchase, into client 2 did not purchase, into client 3 did not purchase. So 0.9 into 0.9 into 0. That's all. Is clear?
Yes, sir. Sir, 10th question I got wrong, sir.
Okay. Any one of you got the correct?
Sir, I also got wrong.
Okay.
I got 0.
It will be 0.
Will be 0.
Okay. Person who got the 0, how? I mean, what was your approach?
Sir, because when 2 will be correct, then the third will also be correct.
Yes.
So there is not such case exist.
Correct.
Yes, sir. Same logic.
Question is saying a postman has 3 posts, okay, to deliver in 3 adjacent houses in his area. But he is not sure which post belongs to the which house. He delivers the post randomly, and random variable X is defined as the number of houses he delivers the right post. Okay. So what is the number of relevant outcomes for X equal to 2? See, if the postman delivers the post in the right post, I mean in the right house, so in how many way he can do? Only one way?
Yes, sir. Sir,
see, X is what? Number of houses he deliver the right post, correct? This is the my X. So what values X can take?
0.
X can take 0
and 1.
1 and 3.
Yes, sir.
He can post the right post.
Yes, sir. Got it.
In not in a in a single house. He can post the in a single. I mean, right post in the correct in a in
one house.
In only one house, right? If I'm saying if he's posted the right post in the 2 correct house, that means third will automatically will be correct.
Third will be automatically correct.
Since
right?
we have 3 houses.
So X equal to 2, there is no something 0.
Yeah.
Relevant outcome for X equal to 2 will be 0. Is that clear now?
Yes, sir.
Yeah. So what about question number 11?
Option D.
So it was
So the last option.
Okay. So how did you approach? It is what is X? X is number of chosen number of girls is chosen students, right? So
yeah. So at X equals to 2, if we are taking 2 girls, and that means 2 boys would be taken since there are 4 chosen. So 10C2 into 10C2, simple.
Yeah. So what value X can take?
0, 1, 2, 3, 4.
0, 1, 2, 3, 4. Yeah.
Because
0,
4
1,
students
2,
we are selecting. Okay. 0, 1, 2, 3, 4. Now we are talking about probability of X equal to 2. We have 10 boys and 10 girls. in how many way? It's a probability. No, it's only outcomes. So for x equal to 2, that means what? 10C2, right? Suppose this is for the girls and remaining 2 will be selected from the boys, right? Suppose I'm saying x equal to 3.
So 10C3 into
NC1.
C1. Okay. Suppose this is 11. For girls is 10. Then what will be about x equal to 4?
10C
4 into 11C0.
Yes, sir.
Okay.
Yes, sir.
So similarly, we have to do that. That's all about random variable. Okay. So any doubt in activity 9.2? Anybody?
I haven't even done it, sir.
Okay. Anybody else who has who have doubt in activity 9.2? Or is this clear for everyone?
Yes, sir, it is clear.
Clear, sir, for me.
Okay. And, what about activity 9.3? It's about only continuous and discrete, right? You are familiar
sir.
with the discrete and
Yes, sir.
continuous.
Yes, sir.
Sir, in the last question, I have a doubt.
Last question.
Yes, sir.
Okay, a random variable x is defined as the length of the hypotenuse of the right angle triangle whose other two sides are determined by roll of two six-sided die. Choose the correct option. Okay, so
I think, sir, it should not be discrete variable x because it can take under root values. So it may be
okay, what is the discrete?
1, 2, 3 integer values.
And in decimal, it's continuous.
Yes.
No.
Yes, sir.
in between two values, it should
Yeah.
not value should not be there in between values.
You
So
can't say like
outcome of die is discrete variable, right?
first thing. Yeah. Second thing, people are making conclusion like if it's in decimal, then it will be continuous. No, it's not about decimal and all things. Continuous is something if suppose I have these things 1, 2, 3. Okay. Suppose I'm going to say a number of attempts to give an exam. Okay. So or clear a competitive exam. So number of attempts is what? 1 attempt, 2 attempts, 3 attempts, 4 attempts, and all things, right? So it's a discrete. Why discrete? It cannot take any value between these 1 and 2, right? It cannot take any value between these two. And thing is there, here I am
and
going.
Moreover,
yeah, I'm here
and
counting.
moreover, sir, we cannot measure them.
Yes, that is the basic main difference between discrete and continuous. So discrete, we have to count. And what about continuous? We have to measure the things, not count the things. And it can take any value between the interval. Okay. So you are saying, suppose after rolling dice, you got 1, 1, 1, 2, correct? So 1, 1 means root 2 according to the this equation. I mean,
Yes,
according
sir.
to the rule of Pythagoras. And what about 1, 2?
Root
1
5.
square plus 2 square, root 5. Okay. Suppose this is the root 2, this is the root 5. So is there any possible any value can be between these two?
No, sir.
No. All the values will be distinct, right?
Okay, sir.
So it is discrete, first thing. And so it will be a discrete random variable. What about the another option?
It will be third option.
Third is clear for everyone. Let's see whether it's correct or not. Yeah, it's correct. So third is correct for everyone.
Yes, sir.
Number of values x can take is 21. It is clear for everyone, okay? Why 21? It should be 36, right?
Some common numbers will be there, no, sir. 3 and
Correct.
6 means 3 and 6. 6
Yeah.
and 3 are same.
Yeah, 1, 1, 1, 2, 1, 3.
Yeah, we have to knock off the similar
1, 5. Yeah, 1, 6. So 2, 1.
2, 1 and 1, 2 are same.
So this thing is same as these things. We will get root 5 for this as well. Okay. So 3, 1, 3, 2, 3, 3, right? 3, 4.
1,
4,
3,
1,
4, 1, 1,
2,
4.
4 3 and 4 4 onwards. So if you see for this we will get same value. For 3 1, for 1 3 we will get the same value. For 3 2, for 2 3 we will get the same value. So you will get some such values like this before this 5 1, 5 2, 5 3 and 5 4, right? Similarly 6 up to 6 5. So how many values? It's 1 2 3 4 5 6 7 8 9 10 and 5 for the 6 1 6 2 6 3 6 4 6 5. So these are 15 values which will be common, right? So how total is 36. These 15 are common, so 21 is the distinct. It's clear?
Yes, sir.
Okay, is it clear for everyone, right?
If anyone is not clear on discrete and continuous, sir, in the tutorial lecture of in that they are telling us, sir, number of sand in that is telling weight of the sand.
Yes, yes.
Weight of the sand, for example, some constant weight you multiply, it is discrete.
Okay. Yeah, come to this first, I mean, previous question. Length of the phone call, it will be discrete or continuous?
Continuous.
It's a continuous. Suppose length of phone call, it can be anything.
Continuous, sir.
1 minute, something second, then nanosecond are also.
So we can measure, na?
Yeah, and we have to measure, and it can be any. I mean, it
Yeah,
can
like
take
we can
any
measure.
value, right? And number of customers visiting every hour in the shop. So it's a discrete.
Yeah.
You can count.
Values.
Yeah, 3 customers visiting the shop,
Discrete
4 customers watching. So we are counting the things. Amount of milk produced yearly by a particular cow. So amount of milk, what?
It can be any value.
Yeah, any value is the different thing.
Sir, it is measurable, sir.
Yes.
It is.
You can't count the milk. You have to measure the milk. Like, yeah, 1 liter, 2 liter, something like that.
Sir,
Okay?
measure the thing.
Yeah, we have to measure the thing. We can't count. And number of accident, it's something we can count. Like 1 accident, 2 accident.
This is countable, sir. So discrete.
Yes. And travel time, it's a continuous, right? And time interval between 2 successive votes,
Continuous, sir.
again continuous. And proportion of people who cast their votes in favor of national party, it's a continuous.
Sir, one indication in the instead of saying per cow, for example, it is a 5 liter can. So that is measurable or countable, sir? 5 liter, 10 5 liter cans are there. So that is discrete or continuous?
No, you are asking about number of can or
milk in the 5 cans. Each
no, it's a, again it's a continuous. So continuous is what? I think you might have missed the week 1, week 2 lecture. So continuous is what? Continuous, that is something we cannot count. Okay, we have to measure that thing. Okay, suppose you have milk. So are you able to count the milk? You have to measure in liter, right?
Yes.
Suppose height of a person, whether you have to you will count the height or you have to measure. I can measure in centimeter, feet and all things.
Yes.
Weight of a person, I can measure in kilogram. The weight is what you have to measure, right? Yeah, 68 kilogram, 53 kilogram and whatever.
Okay, sir.
And suppose speed of a bike,
continuous
because we have to measure in kilometer per hour. Okay,
sir.
So any doubt in lecture 9.4 or activity 9.4? Any one of you?
No doubt, sir, for me. Shaktinath.
Sir, can you explain the 5th question, sir? I got it right, but still.
This 5th one.
Yes, sir, the candy one. Yeah, the candy one.
Okay. I mean, at what point you got the stuff?
Sir, for no candy and 3 candies, I figured that out. What I did is just subtracted it from 1 and just split it into 2 parts. But that is not a proper way to do it.
Okay. So question is X be
That,
the
that's why I'm
number of
asking you.
candies
Like, is there any
present in a
proper
box,
way?
right? X is the number of candies present in the box. There are at most 3 candies in the box, right? That means X can take value 0, 1, 2, 3, right? Now, probability of 2 candies in the box is same as the probability of having 1 candy. So
Either 1/3 or 1/6. Second one, fourth one.
Yeah. See, if you see, question is probability of having 2 candies in the box is same as the probability of having 1 candy. Okay, let's go with the option number 1. So is the same probability same for the having 2 candy and having 1 candy?
No.
No. Come to the second. Here
Same,
probability of having 2 candies same as the probability of 1 candy, but come to this first condition is satisfied. Come to the second condition. Probability of having no candy in the box is same as the probability of having 3 candies. Okay, so this things is correct. I mean this statement is also but now come to the last statement. The probability of having 1 or 2 candies is half of the probability of having 0 or 3 candies. So probability of having 1 or 2 candies is 2/6.
Double.
Right? But it's not half of the 0 and 3. It's a 2 times of 0 and 3. Right? Are you getting my point? That means
Yes.
only fourth
Yes,
option
yes,
is
yes,
correct.
yes, sir.
Because in the third 1 and 2 probability is not correct. Okay.
Got it, sir.
Got it?
Got it.
Yeah. Any doubt in the 6, 7?
Yes, sir, yes, sir, yes, sir. Got it.
Yeah. Any one of you doubt in the question number 6 or 7 in any question?
Question number 7, sir.
No, sir.
Question number 7. Okay. Can you tell me what was your approach so that I know at what step you got stuck? Can you? Yeah, please. Who has not doubt, please move. But there is some background disturbance. Okay. So in the question number 7, who asked question number 7?
Yes, sir. No.
Srijal, right? Okay. So in the question is saying a shipment of the question number 7, a shipment of 20 similar computers to a retail outlet contains 3 defective. So if there are 3 defective out of 20, so how many computers are non-defective?
17, sir.
Correct? Yeah. And if a school makes a random purchase of 2 of these computers, find the probability mass function of the number of defective. Okay. So school makes a random purchase of 2 of the computer. That means X can take value 0, 1, 2. That means 0 purchase, 1 purchase, and 2 purchase. Correct?
Yes, sir.
Now, come to the values. We can compute the values. So X are taking the value 0, 1, and 2. What is the probability for X equal to X? What is the probability of 0? 0 means 0 defective piece, right?
So
that means all computers which are purchased are correct computer.
See, out of 20, 3 are defective. That means 17 are non-defective. First of what is the total number of case? Total number of cases. In how many ways you can choose the 2 computers?
20 C2.
20 C2, right? And
yes.
20
C2,
C2, sir.
defective 17 C2.
Yeah, 0 means 0 defective computer. That means 3C0 into 17C2. Correct?
Yes, sir.
What about probability X equal to 1 means 1 defective? That means 3C1 into
17C1
divided by 20C2. Right? Probability of X equal to 2 means 2 or defective means 3C2 and 17C0 divided by 20C2. Correct? So
yes,
just
sir.
compute the values, you will get the correct option.
Okay, sir. Got it.
So anybody have any doubt in activity 9.4 or we can move?
No, sir, it's clear.
So any doubt in activity 9.5?
Sir, the first one, sir. I couldn't approach it.
Okay, first one. Okay, you know the PMF, right? Probability mass function is nothing but, suppose x is taking value, x is my random variable, x is taking value x1, x2 up to xn. Then probability mass function is nothing but we are considering the probabilistic behavior for each values of x, right? That means probability of x equal to x. For what is the probability for x1?
Yes, sir.
When, for what is the probability when x will take value x2? What will be the
And
probability
x2 and
of
x3.
okay, that is the something PMF. And there is two criteria. Probability of each probability should be greater or
Like we
equal
are
to 0,
distributing probability, right?
and each sum of all the probabilities should be equal to 1.
And the summation would be 1.
Okay, this is the something PMF. What is the CDF?
Yeah.
It's a cumulative distribution function. See, for PMF, from the PMF, we have the idea about one variable, one value, right? When x will take value 1, a single value, what is the probability?
Like distinct points. Yeah.
Distinct point. But in the CDF, suppose this is something which is called CDF. Yeah. So what is the meaning of this? We have to accumulate the probability till point A, till the value A. We have to consider all the probability till the point A, right?
Yes, sir.
I mean, rather than the interested in at a single point.
Yes, sir.
Suppose we are interested at some point, and what is the probability? I mean, less or equal to that point. So we have to accumulate all the probabilities, okay, till that point. So that is something called a CDF. I mean, you can go by the name cumulative distribution function. Okay, so this is the something two fundamentals.
It's like adding.
Question number 1 is saying 3 are red. There are 3 red and 7 blue balls in a bag. Okay, 3 balls are randomly drawn one by one with replacement. Let x be the number of red balls in 3 draws. Then what? Which of the following is the correct probability mass function of x? Okay, so x is the number of red balls, and we are drawing 3.
That actually messed my mind, sir.
So x is number of red balls, correct? And we are drawing 3 balls, right? So x can take value 0, 1, 2,
3 balls,
and 3, right?
Yeah.
Now, what is the probability when x is 0?
3.
Means 0 red ball.
So no red, sir.
Yeah. And we have 3 red and 7 blue. And we have 3 red and 7 blue. And first of one thing, we are drawing with replacement.
7 blues, yeah.
So that means all 3 are blue, correct? All 3 are blue ball. 0 red ball means all 3 are blue ball. That means 7 by 10.
Yes, sir.
And we are doing with replacement again into 7 by 10 into 7 by 10. That means probability of blue, blue, blue. This thing is clear?
Yes, sir.
So I can do 7 into 7 into 7. So
yeah.
Into 7, it will be 343 divided by 1000. Okay. So what will be the probability of x equal to 1? Means probability of 1 red ball.
So 1 red, 2 blue. Yeah.
So what will be the probability?
1 red after 3.
3 by 10 into 7 by 10 into
3 red balls means 3 by 10 into 7 by 10, 7 by 10.
That's all. That's all. No.
And next would be like 2 red, 1 blue, and then all red. Got it, sir. Got it.
See, it will be, it's not, there will be 3 cases. Why? 1 red, 2 ball, or blue, red, blue, or blue, blue, red.
Oh, okay. Like
similarly,
three different arrangements within.
Yes, and similarly, there will be 3 cases for probability x equal to 2. 2 red ball means red, red, blue, plus red, blue, red, plus probability of blue, red, red. Okay.
Plus blue, red, red.
And what is the probability of x equal to 3? All are red. Red, red, red. There is only one case. So
all
it will be
red.
3 by 10 into
Yeah,
3 by 10 into
3 by 10, 3 by 10, 3 by 10.
Okay, it's clear.
3 by 10.
So just compute the value, you will get the
Yeah, clear, sir, clear, sir. I made the wrong arrangement thing over there. Thank you,
okay,
sir.
no issues, no issues. Any doubt in any other question? Any one of you have doubt in any question? Activity 9.5 or lectures, any concept related to lectures 9.5? So we can move for the next.
Sir, I had a general question, but I will wait for once everybody's question is over and your lecture is over. I had a general question about, a general question, sir. If you allow.
Yeah, we'll do. Okay. Yeah. Any doubt related to lecture 9.6, concept related doubt or activity? Any one of you?
No, sir.
Yeah. So in activity 9.6, it's nothing but we have to apply the concepts of cumulative distribution function. Okay. So in activity we do not have doubt. So what about practice assignment 9? Any one of you have doubt? Or okay, you had tried or not till?
I haven't tried, sir, yet.
Okay, just try this. Okay, if you have doubt.
Yes, sir, tried.
Okay. Okay, so
actually I actually had a like confusion. Like I mean, I tried it way, but I don't know if that's a correct like approach. And I don't know if you have the question, so I'm just gonna read it out for you. So there are two friends, Ramesh and Suresh.
Okay.
They are playing book cricket.
This page, this
with
question.
A book having 10 pages. Oh yeah, this one. Sir. Yeah,
okay.
this one.
Yeah,
this one. So this one.
Okay, yeah.
So sir, what I did? So sir, what I did is cases where he will be not out. So first is like first not out. I mean, first chance he got out, and second chance he got out, third chance he got out, and fourth chance he got out. And I made some cases.
Correct.
And so the last thing would be like the he will be not out. So it would be like all the like it's like all the multiplications. I mean, there are 4 possibilities, right? Like if the page 10 is coming out, so he would be out. So 2, 4, 6, 8, I guess. So
okay.
Those values.
Yeah, I will come to this. What is the question is saying?
But sir,
yeah.
Yes, sir. But one thing is like which is bothering here, like. Sir, Ramesh will be not out at the end of his chances. So, sir, here it is my question: like, should I add all the probabilities to get all the possible cases, or it's just like for like it's just like like all like 10 or something? So this is my question.
It's not about
like,
10. It's
I know it's just 1 or 2 steps after my approach.
Yeah, it's about all the chances.
So that is my actually question.
Yeah, Sayan, thing is that it's all about all the chances. Okay. Yeah, I will give you idea. See, they are playing the cricket. Okay, and thing is that an initial score is 0 and maximum of 5 chances. Okay, and they are randomly open a book page. The last digit of right side pages will be added to your current score. This is the thing. Okay, and they will get 0. That means you are out. And you won't have any more chances to play, right? And book contains 10 pages, 1 to 10, with the right side pages containing the even number. So there are 5 even number, 2, 4, 6, 8, 10, right?
Yeah.
And
6, 8, 10. Yeah.
Then probability of Ramesh and scores. This is some PMF. So what is the probability that Ramesh will not be out at end of his chances? So there will be cases that you are discussing. So case 1 will be like that. You can say Ramesh is out in the first chance, right? So in how many ways he will be out? Only one
way, sir.
When he will get 10 and 0 will be there, right?
Yeah, he opens the page 10.
Yeah, So what
Yeah,
about
yeah.
case 2? Out in the second? Out in the second chance, right? If he out in the
So
Ramesh is
that
out.
is also in one way. He
No.
opens.
Suppose Ramesh is out in the second chance, then for the first chance, he has 4 way. He can get 2,
He's
4,
not
6.
out in the first chance. Yeah.
Yes.
4. Yeah, 4.
That means he is not on the first chance. That means 4 way for not.
The 5
for,
minus 1 actually.
Yeah, 5 minus 1 for not being out in the first chance, and 1 way for being out in the
5
second
minus 1
chance.
into 1.
Right? That means there are total 4 ways.
Second chance. Yeah. Got it.
Right?
Yeah.
Case 3 is about out in the third chance. That means he is not out in the first chance, and he is not on the second chance. He is out in the third chance. That means 4 into 4 into 1.
Into 1. Yeah.
That means 4 square.
Yeah. Absolutely.
Case 4 will be out in the fourth chance. That means not out in the first chance, not on the second chance, not on the third chance, and out in the fourth chance. That means 4, 4, 4. So that means 4 cube.
Therefore 4 cube.
Case 5 will be out in the fifth chance. That means 4 is for 4 into 1.
Yes.
So last case will be.
And the last case would be like he's not out. So
not
it
out,
would be
right?
4 to the power 5.
Not out. So it will be 4 is to power 5. So these are the total case 1 plus 4, right? Plus 4 square plus 4 cube plus 4 power 4 plus 4 raised to power 5. These are the total number of ways for his chances, right?
Yeah.
So total chances 1 plus 4 square plus 4 cube plus 4 is power 4 plus 4 is power 5. I don't know what value it will be. So just let's it's A is coming out. Okay. Question is, Ramesh will not be out at the end of his chance. That means 4 raised to power 5 divided by A. I mean, after calculating this.
Okay. So what I did wrong is
Your voice is not coming.
That's the case for the numerator. So I had to add that value as well.
Yes.
Hello?
Yeah.
Yeah, sir. So I was saying like I knocked off the last case. I mean the 4 is to 5. I thought that's the numerator part since he's not out. So I actually knocked off that value and just added others. So that's why I didn't get the answer. Got it.
Oh, yeah. Now it's clear, right? Okay.
Yeah. It's clear, sir. It's clear.
Okay. So anybody have anything else? So you can ask. Otherwise, you can.
In tutorial 6 video, I have doubts.
Week 9.
Yeah. Tutorial 6 video.
Okay. What is your doubt?
So yeah, when we convert it to PMF, x equal to 2, when x takes the value 2, the probability is 0.
1 second.
So that's the doubt, sir.
X equal to 2, probability is 0. Yeah. So 4 by 10 minus 4 by 10.
But same thing in practice assignment, third question.
Okay. Practice assignment, third question. Okay. Question might be different for everyone. This one?
This one, yes. No,
okay,
no, sir,
yes.
this one, no, this one.
This one?
No, sir.
Question might be different for everyone.
The discrete random variable x has the following probability function. P of x is equal to kx for x equal to 1, 2. That's the question.
Okay. Let me refresh. Because after each refresh, you'll get some different set of questions.
Yes, sir.
So this one?
Yes, sir, this one.
Okay. So what is doubt? What is the value of k?
As mentioned in the video, if I for x equal to 2, what is the case for x equal to 2, sir? If it is 0, then the total k value is 1 by 2. I got.
No. I did not get your point here. I mean, how you are relating that question to this?
Sir, it is 1 for ones and 2 for 2, right?
Yeah.
I mean, sir, kx would be once for 1 and kx would be once for 2. That means once it's k into 1 and 2 into k for 2.
See, it is given that probability of x equal to x, PMF means it will take the value kx when x is 1 and 2, and it will take the value kx minus 2 when x will be 3, 0 otherwise. Okay. That means,
sir.
Okay. So here we need to find the value of k. How will you find the probability of value of k? Since it is the PMF, I know if it's PMF, then sum of all the probabilities should be equal to 1. Right? That means, see, x is taking value 1, 2, and 3 here. Probability of x equal to x is what here? Kx minus 2, and for again it's kx. For 2 again it's kx, and it's kx minus 2, right?
Yes,
so
sir.
For finding the value of k, I know the sum of all the probabilities is equal to 1. That means kx plus kx minus 2 should be equal to 1. So it will be kx plus kx minus 2k equal to 1. So it will be 3kx minus 2k equal to 1. Okay, if you will take k as a common, so it will be 3x minus 2 equal to 1. So k is nothing but 1 upon 3x minus 2. Right?
Right.
Okay, 1 second, I made a mistake actually. It's 1, then it will be k.
1 by 4.
So we need to add the values. I mean, multiply the values.
Yeah, actually it's a 2x, so it will be 2k, right? And if it's 3, then it will be simply k. So it will be 4k equal to 1. Okay.
Yes, sir. K equal to 1 by 4.
K equal to 4. Yeah, 4. This was, I made a mistake. Sorry about that. So it's a k is equal to 1 by 4. That's about PMF. Okay. Now you are getting confusion about CDF to PMF, right?
Yes, sir.
Okay. See.
Actually,
suppose, yeah, I'm going to take an example. Suppose x is 1, 2, 3, and 4, and PMF is let's say it's 1 by 4. It's a 1 by 2, 1 by 8, 1 by 8. It's add up. Is it add up? 1. It's 2 by 8, 4 by 8, 4 2. Yeah. If you add all the probabilities, 1 by it's 1. So that means this is the PMF. Okay. All the probabilities is greater than 0 as well. So what is about f of a? Now, for computing the PMF, it's a simple things. We have to consider the before 1. Suppose a is less than 1. That means 0.
Yes.
A is 1 and less than 2. That means
1 by 4.
1 by 4?
Yeah.
You can draw a plot also, right? Suppose this is 1. Before 1, it's 0. From 1 to 2, so 0 plus 1 by 4, right? So similarly, we can do. So what about 2 and up to 3? Before 3, I have to accumulate the probability till 2.
So it's 1 by 4 plus 1 by 2.
1 by 4 plus 1 by 2, that means 3 by 4.
1 by 4 plus 1 by 2.
Yeah, 1 by 4 plus 1 by 2, that means 3 by 4.
3 by 4, yes.
What about 3 to 4? 1 by 4 plus 1 by 2 plus 1 by 8, that
That's
means
3 by 4 plus 1 by 8.
7 by 8. What about a greater or equal to 4? 1.
Yes.
Right?
Right.
So this is something we got the CDF, right? What about PMF? Suppose from here I have x 0, 1, 2, 3. No, so not 0. 1, 2, 3, and 4. Okay. So probability x equal to x means the point where jump is there, we have to subtract the probability, right? So for x equal to 1, 1 by 4 minus 0. It will be, see, for finding the CDF, what we have done, for 1, we have already added the probability less than 1 and less or equal to 1, right? So we need to subtract for a single point.
Okay, sir.
And what about probability x equal to 2?
1 by
3 by 4 minus
1 by 4.
That means 2 by 4, that means 1 by 2.
Yes.
For x equal to 3, this will be 1 by 8.
Yes, sir.
And what For x equal to 4, it will be 1 by 8.
Yes. Okay.
And we got the same PMF.
Okay.
And one more thing you can do by the diagram. Suppose this is my x and this is the px, probability of x. Okay. Suppose this is the 0, this is the 1, this is the 2, this is the 3, and this is the 4. Okay. So for before x is less than 1. Okay. I'm going to, this is 0.25. Suppose this is 0.5. This is 0.75 and this is 0.1. I mean 1, not 0.1. So for x is less than 1, we have probability 0, right? And equal to 1 less or equal to 2. That means from 1 to 2, I have probability 0.25. That means 1 by 4, right? I'm going to draw this CDF, right? Okay. And from 2 to 3, what is 3 by 4? So 3 by 4 means what?
Jump to 0.5.
So 3 by 4 means what? 0.75, right? So that means 2 I'm including. So 2 to 3 is 0.75, right? Are you getting my point, or is everyone getting my point?
Sir, but 1
yes,
to 2
sir.
it is half, no, sir?
Sorry?
0.5.
Yes.
1 to 2.
1 to 2. I'm going, see, I'm drawing the CDF, not
Okay.
See,
okay.
A less than 1 means 0, right? A less than
Right.
0, we do not have any probability. 1 to 2, 1 by 4. So 1 to 2, it's 0.25. 2 is included, 3 is not. It's a 3 by 4. That means 0.75. So 2 is included,
yes.
3 is not.
Okay.
3 to 4 is 7.7 by 8. That means 0.875. So I'm going to say that suppose 0.875 is there. So 3 to 4. So 3 is included. If you see this inequality, 3 is included and 4 is not. So for the 4, no solid point. Okay. And greater or equal to 4, it's 1.
It's
so
1.
greater or equal to 4, it's 1. Okay. This is the something CDF. From the CDF, how we will get the PMF, I mean probability for each value. See, jump.
Sir, the jump, sir. So the jump, sir.
So for
jump.
x equal to 1, what is the jump?
Yeah, the
1
jump
by
value.
4.
1 by 4. 1.25.
Okay. And for x equal to 2, what is the jump? 0.25. I mean this subtraction of this one.
It's 0.5.
0.75 minus
0.5, sir.
0.5.
Okay.
0.5 means 1 by 2.
0.5.
What is the jump for this? 0.875 minus point of
0.125.
0.75. So we will get 0.125.
125. Yes.
No. Point.
Yes, sir. 0.125.
Yeah. Sorry. Yeah. So that means 1 by 8. This jump is 1 by 8, right?
Yes, sir.
And what about this jump? It's
Same.
again 1 by 8.
0.125.
So from PMF, we have to subtract the values like this. We have subtracted. And for the CDF, we have to add. From this graph, it's clear how we can proceed.
Okay, sir. Fine.
Okay.
It's clear, sir.
Okay. Anybody have anything else?
So this lecture would be available under live session.
Yeah, you can rewatch on the YouTube also after the end. Okay. Yeah.
Thank you, sir.
So anything else, anybody, or should we wind up the session?
I'm good, sir.
No, sir. So far, sir, no doubt.
Okay. Anybody, anything else, or should we close?
Sir, I took time for a question, sir, actually from you.
Sorry, Asu?
Sir, I have a question. I discussed that I would ask not related to the course question, but general.
Yeah. Please ask.
Yeah. So my question is so as it's clear from the pace right now that I mean till we have to go till 14th, right? Till like week 9th until week 14th, right? When we have the final.
No, it's about week 12, not 14.
Yeah. Okay. So 12. So
yes.
So it's clear now that it will be very difficult to keep pace with all 4 subjects. So what are the possibilities that what will happen? Like, let's say that even if we try, if somebody tries and but they're not able to submit the next assignments or is not able to understand, or he fails in the exam. So will they have to redo the whole thing, or like how it will be? Like
no, you are saying you are not able to give the exam.
Not able to, not able to. Maybe, you know, if with the pace, this pace, you are not able to keep up, and you fail. So so if somebody fails, will he have to do the whole assignments again, or how it will?
No, thing is that so there is grading pattern. How had you gone through the grading pattern in the portal itself? There are grading pattern in that grading pattern. All the things is mentioned, right? One second, let me tell you where it is. You can just go in the course introduction. Okay, there are a section of general instructions and important links. Okay, and there is some grading pattern and timeline document of the September term 2022. So you can click here and you can see the grading pattern. So all the things is mentioned there, right? All the things means when the exam and what is the grading pattern, how many how many graded assignment you have to submit out of total for quiz 2 and term and all things. So please go through that things. Okay, if still you have any doubt related to that, so you can ask with the support team. They will clear.
I will go through it, but can you just answer this question, like like it's not. I mean, I don't think it's this thing that.
No. Thing is that such type of query is handled by the support team. Okay. Like, yeah, such type of query is handled by support team. So you have the email ID of support team. It's nothing but support@onlinedegree.it.ac.in. So you can mail to them. Okay. So they will answer. Yeah.
Thank you.
Thanks. Anything else? Anybody?
Sir, on a similar line, actually beyond week 6, I'm finding it very difficult to keep up. I have found it very difficult to keep up. I made a mistake of enrolling for all 4 subjects, and within 1 month, I have to prepare for all the full term.
Same situation.
So the only thing I can do, you have to somehow you have to manage.
Sir,
but initially the 4, you know, when we had to judge from the 4 classes, it was at a nice pace.
Pace is, I think it's something. Yeah, it was normally it's really contains release and all things. It's on its own pace. But thing is, in the last few days before, there were some festivals and all things, right? So due to that might maybe scenario for creating the problem, like not completing the course. Yeah, from week 5 onwards, I agree. Week 5, week 6, week 7, week 8 is little, but with something, it's a little bit difficult to understand. But yeah, if you have more practice, then you can easily handle the things. So I can say only the things you have to practice and how things. So this, yeah, we are here for you guys. I mean, for taking sessions, for taking doubts. So apart from your practice on things, you have doubts, so you can ask, we can discuss.
Sir, do you think it is it is a good idea to bypass the content and continue the assignments, or would going through the content make things easier?
No. If you go with if you go each lecture wise, right? So below the each lecture, there are some activity questions related to that topics. So if you are if you will understand the lecture, all the concepts, then and you are able to solve the activity question, that means you are getting the idea related to that topics. Okay, so this is the something there are activity questions below the every video, and apart from those, you can try the practice assignment, right? After some calculating the after solving some basic questions related to the lecture video, in practice assignment there is some difficult question. And in the graded assignments, if you are able to do all the things, activity and practice, then you can easily do the graded assignment questions. And we are also conducting the solve the session before 1 day of the graded assignments. Okay, so it's on you. I mean, how you are managing the things.
Yes, sir. So definitely, if something is lacking and some efforts have been
Yes,
neglected in the
some
past,
efforts you have to put, but see, every individuals have different approach, right? Some people want to direct solve the graded assignment. Some people did the activity, then they have done the practice, then they are doing the graded. So it's some individuals approach, as I can say. So it's on based on everyone. Yeah, that's the things I can say for you. Yeah, but somehow you have to manage the things. In the next term, you can take the less number of courses. Like suppose someone is working professional, then according his time, they can take one course or two courses or things. So same things you can do for the this term also. But now it's a quiz too. I mean, just check the grading pattern and you can ask it. The only thing I can say you have to, I mean, see, everyone's have different ability and different approach. So that's something I can say. But yeah, it's,
okay.
Yeah. Anything else?
Yes, sir. Actually, nothing, sir. You said everyone has a different approach.
Yeah, it depends. Like suppose you are a student, then you are doing another degree with this course, then you have less time. Suppose someone is doing only this degree, then they have lot time. They can do all the questions, more questions. Suppose someone is working professional, then they have less time, so they have to manage according to him or her. So it's depends.
So actually, my question was regarding the content. Like I tried a couple of weeks. I tried bypassing the content and doing simply seeing the tutorials. But sir, is there a shorter way, like studying other books? Will that make the task easier, or like I have a big gap, academic gap? I haven't studied the books for a long time. So just I'm asking your advice. Like if I pick up 12 standard books or
Yeah.
my
For
task.
more, for thing is that see, first of all, I will say the questions, number of questions in practice assignment activity and graders is sufficient if you are doing all the questions. Apart from this, there is a book mentioned in the portal as well. You can prefer this, and along with this, you can prefer the NCERT books and all things for getting the ideas for mediation complex and all things. So it's you
My
can prefer.
question was like if I want to speeden up my learning process.